So, we will module 5 start. So, module 5 first topic is rotation motion. Rotation motion is already studied. That is, a particle circular rotate. That is, circular particle movement rotation motion. That is, all the particles will move along a circular concentric path. That is, movie rotation motion. As example, we will pulley. That's we will movement. It is moving through a circular path. A circular shape pulley. For example, shaft in the rotation. Wheel cycle shaft. That's circular rotating. Flywheel. These are examples. At the kinematics of motion. Kinematics of motion is a body, a rigid body, a fixed axis rotate that body position determines the angular displacement. That is, a body in a circular path or fixed axis rotate a body displace movement. It is described by the angular displacement of the body through the axis of rotation. Angle of displacement is theta. Theta is angle of displacement. Theta is angle of rotation. So, that is measure in radians. So, if a constant body displaced uniform motion uniform rotation. This is a body rotation. This is a body fixed axis. So, rotate the body A and B angle. Angle of rotation. Angle of displacement. A and B body displaced. This is the axis of rotation. Displacement of the particle is theta. Measure in radians. That displacement of the particle in circular motion angular displacement theta. Theta is angular displacement. In d theta by dt displacement divided by time. Displacement divided by time velocity. So rotation case angular displacement divided by time angular velocity. So angular velocity is d theta by d theta. Rate of change of angular displacement. So change angular displacement omega. Represent omega. Angular velocity represent omega, which is equal to d theta by t. Theta in radians, t in seconds. So radians per second. This is angular acceleration. We represent alpha. Alpha is d omega by dt. That is angular velocity with respect to time which differentiate angular acceleration. So d omega by dt. Here omega is equal to angular velocity, which is equal to d theta by dt. That is omega d theta by dt. So d square theta by dt square radians per second square. So displacement in a unit is radians. Meter is radians. So if radians per time square radians per second square. So that's what we alpha is d omega by dt, angular rate of change of angular velocity. With respect to theta, numerator and denominator theta multiply. So d omega by d theta into d theta by d theta. dw by d theta d theta by d theta is the rate of change of angular displacement and angular velocity. So omega. So alpha is equal to omega into dw by d theta. This revolutions per minute angular velocity equation angular velocity 2 pi n by 60. N angular velocity n. So revolutions per second. If angular velocity is represented in revolutions, so revolution is 2 pi radians. That is 1 minute is 60 seconds. The equation W is equal to 2 pi n by 60 radians per second. N is the angular velocity in revolutions per minute. This equation is angular velocity. N is the angular velocity which is given in revolutions per minute. So, this is the derivation. Just to understand. That's the video. Okay, derivation. Okay.